Thank you again, everyone. Good morning.
Good morning.
Thank you for joining us today. This is our third Coffee with the Dean, but the first Coffee with the Dean in 2021. And the topic of this conversation today is around clean water and sanitation, one of the goals that was set by the United Nations around Sustainable Development Goals. And we think this is not only timely, but is important because we are in the Great Lake region and economy of our state is depends on the Great Lakes that we are surrounded by. The study shows that Great Lake provide Michigan with about 800,000 jobs, nearly 25% of Michigan payroll. And this is not about just tourism or recreational boating, but it's also about farming, manufacturing, mining, and energy production. So it is most important for us to make sure we preserve these Great Lakes waters that we have. We have put together a group of panelists and moderator, Dr. Schuster, who I'll introduce shortly, that will be talking about the safeguarding the drinking water, microplastics in natural and engineered water systems, and also talking about wastewater bound epidemiology, and more importantly, smart, like everything else, sewer systems. With that, I don't want to take too much time. I would like to invite Dr. Bill Schuster, who joined us as the department chair of Civil and Environmental Engineering in 2000, fall of 2000, to start the introduction of the panelists and say a few words about his department and the work that he's doing. He is an authority in wastewater management as well. So with that, Bill, you have the mic.
Hi, folks. Bill Schuster. Go ahead and advance the slide if you would. And then you can go to the next one. And just wanted to give a brief introduction. I come from 18 years of work at the United States Environmental Protection Agency with the Office of Research and Development, Cincinnati, Ohio. Pleased to be here, proud to serve in warrior, advancing our warrior spirit here at Wayne State Civil Environmental Engineering. And just want to take you through one of our recent research efforts here. And this is what we would expect of any contemporary university or college. And this is participating and gathering data towards effective wastewater-based epidemiology. And here at Wayne, Civil Environmental, and with the School of Medicine here at Wayne, basically we have an interdisciplinary team from across the university working on this. But what's important here is during the pandemic, we have basically a novel virus that is causing COVID-19, the infectious version of this pandemic. And not to interrupt your breakfast if you're still eating, but the SARS-CoV-2 viral material actually sheds from infected individuals in fecal matter. And this is, of course, when we flush the toilet, this is transported to wastewater via septic sewers. So the proactive monitoring for viral material in wastewaters from our congregate housing, our dorms here at Wayne State, give us a leading indicator of determining when and where an outbreak might start. So this is very important work. We were funded by the state of Michigan and joined a network across Michigan to develop standardized approaches, use state-of-the-art equipment, in this case a digital drop polymerase chain reaction protocol to analyze for finding this viral material in the haystack. That's the needle in the haystack of wastewater, which is a complex mix of, various microbiota and other compounds. So this has been a campus-wide effort. We're engaging with the Detroit Health Department and of course the state of Michigan on this. Next slide, please. So moving from the contemporary, I just wanted to introduce the focal United Nations sustainability goal. But before that, it's important to define sustainability. We always want to define our terms. In this case, it's social equity, and then co-occurring with economic stabilization and environmental quality. And to this point, we've developed a program, a Master's of Science in Environmental and Sustainability Engineering. What's different about this is that we're incorporating and giving upskilling and training. Sustainability is a bit of a mindset, and it affects how we engineer, what are our constraints and prospects within for a certain engineering challenge. And so when we're looking at goal number 6, ensuring access to water and sanitation for all, sustainability is a cornerstone to this effort, in attaining this or achieving this goal. One of the sub-goals, 6.3, we're looking at improving water quality by reducing pollution, eliminating dumping, and minimizing the release of hazardous chemicals and materials, and halving the proportion of untreated wastewater, which is something that I'm very interested in, and substantially increasing recycling and safe reuse globally. Next slide, please. So expanding on the idea, wastewater management is foundational to halving the amount of septic flows that go into our surface waters and source waters that we use for example, drinking water. Our gray infrastructure, our built infrastructure that's largely underground, these, basically, we're looking at a generic wastewater collection conveyance system. And during dry weather, these systems tend to work pretty well. During wet weather, when we combine the rainfall runoff volume with the septic volume and whatever else might be in our wastewater system, we do have what are known as combined or septic sewer overflows. And so as our infrastructure changes and actually degrades over time, due to use and just increased loading from a changing climate pattern, we really need to be thinking about how do we effectively shift away from or manage and decrease the frequency and activation volume of these sewer overflows. Next slide, please. So this would help, by again reducing these system overflows. These are the services that we use 24/7, 365, but we need to reduce these costs, which are externalized to the environment. And so with that brief introduction, some of the work that I've done in the past and some of the work that I'll be doing ongoing here at Wayne State and leading great faculty here, I'd like to introduce Dr. Yonglei Zhang, who continues to pursue research in the management of emerging contaminants in our urban water cycle. And currently, her research focuses on microplastics. And so I'll ask Dr. Zhang to please take it away.
Thank you, Bill. And so next slide, please. I think. So good morning, everyone. It's my pleasure to be here to share of my research work. The overall research goal in our lab is to develop water energy-related technologies combined with life cycle assessment modeling tools for environment management and sustainable development. So we do both laboratory studies, field studies, as well as system modeling. Next, please. So we have 4 major research areas here, including emerging contaminants and water quality, wastewater, waste to energy and resource recovery, smart environment monitoring, and life cycle assessment modeling. Today, I'm going to focus on research theme 1, that is emerging contaminants and water quality, particularly microplastics in water. Next, please. So microplastics are small plastic particles smaller than 5 millimeter found in the environment. There are all sorts of different shapes, including fibers, beads, foams, films. The size can go down to micrometer and nanometer size. There's two major sources. The first one is come from, we call that primary microplastics. So basically mainly come from the intentionally manufactured microplastics, such as microbeads that has been widely used in cosmetics and all other industrial use. The second source is called secondary microplastics that come from the breakdown or fragmentation of improperly disposed plastic debris in the environment. So the microplastic has been increased concern in the environment, particularly in the water, because they have been found in all sorts type of water system, including oceans, fresh water, even in drinking water. For example, a study found that the concentration of microplastics can go up to 7,000 particles per liter in raw water sources. And even in treated drinking water, it could be 300 to 500 particles per liter in finished drinking water. It can also go to our food supply. So because of wide presence of microplastics, it's not surprisingly that they also found in human beings. So although the health impact of microplastic to human being has not been studied clearly, but some animal studies does show that the ingestion of microplastic could cause some development disorder, inflammation, and gene expression. Next, please. So in our research group, we have two research objectives in this area. The first is to understand the feed and transport of microplastics, as well as consequential impact on ecological and human health. The second is that we try to reduce microplastic pollution through the remediation campaign and technology development. So thanks to our founders, so we have a number of projects we are taking on right now to address these issues. Next, please. I would like to highlight one aspect of all our research projects that we are taking on. So basically we take a interdisciplinary and very collaborative approach to address the issue of microplastic pollution. For example, we collaborate with water industry and water authorities such as Great Lake Water Authority to monitor microplastic water systems. We also work with business partners such as InWave Optronics to develop and commercialize our sensor technologies. We work with community and nonprofit organizations for remediation campaign. And we also work at other university and K-12 schools for public education. So the overall goal of our research effort is to raise public awareness of microplastic pollution in the environment, and at the same time to develop technology and also conduct remediation campaign to reduce the pollution sources of the microplastic in the environment. So if you would like to know more about our research, please visit our website of microplastic.wen.edu. You can find a lot of information about our research in this area. Thank you.
Thanks so much, Dr. Zhang. Next, I'd like to introduce Dr. Carol Miller, and we're proud to have Dr. Miller here at Wayne State Civil Environmental. She's the go-to person in so many ways for water resources in Michigan, across our international borders, which are local to us, and really across national, international water resources that she challenges. So currently she directs the Healthy Urban Waters program here at Wayne State, and focuses her research on the urban water cycle with an emphasis on emergent exposure pathways driven by legacy volatile organic compounds in the urban subsurface. So I welcome Dr. Miller to the table. Take it away, Carol.
Thanks very much, Bill. We can go ahead and advance to the next slide. I wanted to mention a couple things before getting started on my presentation. First off, I noticed in our list of attendees today that we have quite a few alumni of our civil and environmental engineering program, and I am just so thrilled to see that. And as Bill was just mentioning, we have a variety of go-to people within civil engineering for these sorts of environmental questions. Some of you, when you attended our department, we may have only had 2 environmental engineering professors. I wanted to mention that we now have 5 environmental engineering specialty professors that work within our department, but also engage across the university. Many more engagements these days with the medical school and with the social justice, communication, and so on and so forth. So I guess I would also just toss out there an invitation to those of you that are in the audience to get a hold of one of us maybe and arrange a visit to the department and kind of see what we're up to these days. So Healthy Urban Waters is a program for which I am the director of, and this group is really poised on better understanding the watershed and the water resources that connect Lake Huron, that is the upper Great Lakes, with the lower Great Lakes, so Lake Huron to Lake Erie. And one of the projects I'm going to talk about today is data collection from water monitoring locations along this network that connects Lake Huron and Lake Erie. Next slide, please. As you can see here on the left, with the various dots that are shown with names, most of these are names of cities next to those dots. Each of these dots represents a drinking water plant along the Huron to Erie corridor. All the dots that are shown there, even if the name is showing up on the Canadian side, those dots are actually US drinking water intake points. And so you can see that there are a lot of points along this corridor where communities are pulling water out for primarily for consumption. And at each of these points, there's quite an intricate set of real-time monitoring instrumentation that has been set up to gather data about water quality. One of our projects is focused on sort of networking all of that data that is coming from those various points along this corridor and putting them into a communications platform so that regulatory groups and utility organizations can look at that data to get an idea of changing water quality patterns. So data that comes from the left, you can see the arrow that goes to the right, goes into a real-time data website that provides data instantaneously to utilities along the corridor. That data is then filtered a bit more and ends up in a public database that resides here at Wayne State University, where anybody can look at that data. Next slide, please. So why is this data important? Well, one thing I should mention is that corridor that we just looked at provides drinking water for upwards of 5 million people on the US side and the Canadian side. So from that respect, I think the significance is clear, even if only looking at that particular point. Also, of course, fishing is quite an important activity within that corridor. We have some very important urban beaches along that corridor. So there are a variety of reasons why the corridor is so significant. What can this data system do? Well, I have a couple points here. You can look at the data to, the first most obvious is probably to do some spill notifications. So as upstream points notice some degradation in water quality, that information can be sent downstream. What can be done with that information? That's a whole nother question. How will the utility downstream respond to that information? But that's a different presentation. We can also look at the data to determine if there's temporal trends. Are there any sorts of changes associated potentially with climate change or with land use changes? We can also look at the data to determine, are there any significant changes that might be caused to quality issues of the monitoring equipment? Do we need to go in and change the monitoring equipment? Next slide, please. One of the areas that we've been working on with computer science and our industrial engineering folks is to come up with a smart system that can look at the data and understand what data is true, what data really is reflecting the condition of the corridor, whereas data that is maybe a false positive, data that is suggesting something else. And so a lot going on in terms of trying to understand messy data, because we certainly get enough of that. And you don't want to cause public outrage if data comes up showing a problem and yet really there isn't. Another slide, please. Again, this curve looks familiar to many of you, I know, the DO-SAG curve, but again, you can find problems with equipment by looking at data gaps. Another slide, please. This present state of the network, we have more than 19 million records of water quality. The public database is up and working. And I believe that's my last slide. And I want to make sure we have lots of time for our next speaker, Randy Rogers.
Thanks so much, Carol. And I'm glad that we were able to get some insight into how we're monitoring the urban water cycle here in the Great Lakes area, Southeast Michigan. So you can get a top-notch education at Wayne State Civil Environmental Engineering, but for those who are still in our program, who are on the call today, those who have graduated, gone out and done great things, it's really what you do when you get out. It's what do you do with that training. And I introduce Randy Rogers today, who's a unit president of CDM Smith's Technical Services Unit. And over the last 40 years, Randy has taken it to the top, taken his civil environmental training here at Wayne State and built on that to create a high level of infrastructure integrity in many cities around the nation. And it's this type of service, basically sustaining critical civil and environmental infrastructure services. And so very pleased to have him here, and hats off to Randy. Go ahead and take it over.
Thanks, Bill, and thank you everyone for joining us this morning. The Dean asked me a couple of weeks ago or a month ago to talk about topics that are pushing our water industry, and particularly what CDM Smith is working on to support our water industry. Just as a background, CDM Smith provides water, transportation, and environmental services. About 60% of our revenue comes from water projects and 25% from transportation. The remaining is environmental. But at the heart of all those things, what we're seeing, if I can go to the next slide, please, is that there is a nexus forming between solutions that we're performing for our water clients, our environmental clients, and our transportation clients, and it all surrounds digital solutions. The mating of automation, electrical, information management, water treatment, wastewater treatment, water collection, water distribution, wastewater collection, and visualizing that data to make decisions faster, quicker, cheaper, lower, meaner, etc. So this information technology is at the forefront of everything we're doing, especially in this pandemic time. Clients are asking us to do more for even more for less than we have in the past, because the revenues are down. Road user charges are coming up for our transportation clients. Right now we're not selling as much water. Our clients are wrestling with whether they fund their put more funds into their operating costs or invest in badly needed infrastructure capital improvements. So digital solutions is helping with that. We see a lot of use now of drones for doing things that we used to have people do, driving around in cars. They're enhancing or replacing labor-intensive field data collection. At the job site I'm at today, we're using them for both reporting the progress of construction as well as material takeoffs and cut and fill operations. And then with the mating of BIM technologies and virtual design and construction through lenses like you're seeing here, the Oculus Rift, HoloLens, Tremble Lens, we're actually taking BIM VDC processes out to the field so we can bring the model right out to construction and then ground ourselves to what's being constructed, if it's being constructed right, and the progress of that. So anything that helps clients do things faster, cheaper, quicker, with less effort is what I'm seeing driving our industry right now. Next slide, please. One of the biggest hot topics right now in water treatment, and no, I shouldn't say water treatment, it's everything, because this is a gift that has keep on giving. It's the miracle of modern chemistry back in the 40s with the onset of Teflon and then foam, fire suppressants, polyfluoroalkyl substances, or PFAS for short, is out there. Michigan has some very tight regulations coming up on PFAS removal. California here, these are clients that are undertaking PFAS removal projects right now, but it's driving our industry. The current technologies, granular activated carbon, ion exchange are there, but GAC can't be regenerated from PFAS. You have to find virgin GAC, granular activated carbon, to remove it. And ion exchange is the same thing. There's no regeneration process. So we're working with a number of research labs in the area of what they call foam fractionization, where we actually remove and concentrate, and then that concentrate looks very, once it's concentrated a number of times, we can use a process called electrochemical oxidation for its actual destruction. So we get rid of this gift that keeps on giving. It's in the air, it's in the water, it's in the wastewater. Immediate concern is groundwater supplies, where remediation is necessary. But it will take on larger scales as our water plants start regulating this. In California, they're looking for non-detect levels, parts per trillion. So this is a very big hot topic for our water clients right now. Next slide, please. Dr. Schuster talked about the wastewater-borne epidemiology work that's going on. We're working with Wayne State, Michigan State, and GLEWA and the city of Detroit on their project, where they're actually looking at the RNA signals of the COVID-19 virus. And what we're finding is that this whole RNA signal technology is on the verge of actually being automated, so that we can, when we quote smart sewer right now for virus signal detection is, okay, sample it and then take it into the lab. And I think we're down, Bill will probably know better than me, but I think we're down to getting maybe answers in 24 to 36 hours on what the—
That's exactly right.
Yeah. So there are a couple folks we're working with that are prototyping. If you could envision a level sensor or a flow meter sitting on the bottom side of a manhole cover, and that being able to select an RNA signal for the flu virus of choice, the COVID virus of choice, and then putting those in reaches of the sewer so that you can report to a health department or the city management where the next bloom of COVID-19 or flu virus is going to occur, so we can send out early warnings to those areas of the city. And that can even be expanded into naval. The Navy is very interested in this aboard their aircraft carriers. It could be in campuses to quarantine campus dorms, or at least get a heads up on something that's blooming. There's a very interesting technology, very accelerating technology that has a lot of benefit going forward as a result of this pandemic. Next slide, please. Thank you. And then at the heart of it, for 40 years, I've been asking our folks, I said, can we do more than 3 things with automation in our water treatment plants? So enter the onset of artificial intelligence. Rockwell Technologies, Alan Bradley, now has an artificial intelligence module that plugs right into their program, Logic Controllers. And this brings machine learning right to the heart of our wastewater and water process controls. We have our process inputs here going into the PLC program on the Logic Controller, artificial intelligence module. We populate with that with known intellectual property, cause and effect relationships, and then let the machine start learning and developing a confidence level. When its confidence level gets to a certain point, it can start making machines decisions for you and virtually act as a co-pilot to an operator that's running on a water plant or a wastewater plant. So this is accelerating very quickly into the market. What was it? Arnold Schwarzenegger and the Skynet? Artificial intelligence taking over our process control now. Next slide, please. And so with all these things going on, and I'm sure you all have your own activities and successes and initiatives going on, it's important to remember that exposure of our students to these technologies and the things that are to come are important. So opportunities to provide co-op and internship opportunities. I've got to bring on 83 interns for the summer. This year, the dean wants me to bring all 83 from Wayne State. I don't know if I can do that. I do have to spread that around a bit. But these type of things, new technologies that I'm talking about, are important for them to get introduced to. Partner on research efforts, like the GLEWA work we're doing with Wayne State and Michigan State on the wastewater-borne epidemiology, and there's always funding initiatives that are important for the success and growth of the college and the university.
Thanks so much, Randy.
Thank you.
Excellent presentation, very integrative.
Thank you, Randy. It was a wonderful presentation by you, by Dr. Yongli Zhang and Dr. Carol Miller. Some of the work that we are doing, of course, there's a lot more work that is going on with the faculty. Dr. Miller mentioned we have now a number of faculty, not only in our Department of Civil and Environmental Engineering, but across the campus that we are building a network, because Wayne State is a comprehensive university. We are building a network of experts to address some of these issues. And Randy, I'm okay with 82 interns from Wayne State. 82. I'll keep one for you. But the reason we want you, because you're getting the best students who are really having a work experience, real world knowledge that they can bring in to this effort. At this time, I think we can first maybe open it up for questions, and then see if how we can go from there. The time allows us to ask questions from the panelists.
We do have a question about whether participants here will receive the presentations. Are we planning on posting these?
So the answer is yes. We will put this on our college YouTube channel. The previous 2 Coffee with the Deans that we had, in October and November. Those were posted already on our YouTube channel. One dealt with mobility, the other one was global engineering. This will be also posted there as well too.
Perfect.
And in order to get to our YouTube channel, if you go up to our engineering.wayne.edu website, the main website of the college, go way down the bottom of the page, you will see the YouTube symbol. You can click on it and that will show you what we have there.
I do have a question for Roger. I live in Santa Ana, California. I'm serviced by the Orange County Water District, and we recycle 48% of our wastewater, soon to be 62%. Now you have me curious hearing about microplastics and the other items. Have you had any data from our water supply out here? Because we are one of the few recycling wastewater.
Yeah, California is leading the way on the PFAS initiative. Michigan is a close second because I've never seen such tight constraints and such regulatory ramp up. We don't know, what the regulatory limits should be. It is in everything we're doing, and you recycle it. It's in every place they use foam for firefighting. Here we just had a big fire in the Houston Ship Channel last year, and all that went out someplace to the oyster beds somewhere in the Gulf. So it's become a gift that just keeps on giving. So California's taking a lead on regulation of the PFAS constituents. Like the job I'm chasing right now is in Anaheim, California, and they are looking for non-detect levels. When it comes to regulation, we always look to California as being a first, but Michigan, I think probably as an onset of the Flint episode, is taking a very aggressive stance on regulation of the PFAS as well. And I know you recycle. The question went to recycle, so I'm telling you, whether it's if it's in the water, it's going to be in the recycle water as well.
Indeed.
We have a question in the chat from Ed. He asked, has Wayne State University participated in developing solutions for municipal water problems in communities like Flint, Michigan?
And the answer to that is a qualified yes. Dr. Sean McElmurray, one of our environmental faculty, has been over the long term engaged and using his formidable research abilities to determine what are the engineered approaches that are best going to serve the residents of Flint, Michigan. And this is an ongoing effort. It spans not only the heavy metal contamination, but also the Legionella outbreaks in Flint, Michigan. And as you know, this has come up, basically erupted once again within the courts with indictment of several individuals from that time period. And I think Carol, do you want to unmute or?
Thank you, Bill. Yeah. Sean Dr. McElmurray has been very involved in leading efforts in Flint. Wayne State University has also had faculty from social work and communications very involved and on the ground in Flint doing work. Sean was actually leading a very coordinated effort that included engineers as well as faculty from the med school, social work, and so on.
Thanks. That predates my chairship here, but we have a very strong interest and capacity for interdisciplinary work here. This is the way that we work towards sustainability. When we talk about meeting social equity, economic stabilization, and environmental quality goals, this is the only way forward to achieve that.
Thank you.
All right, we have another question from Richard. I'm curious about the cost benefit of the viral monitoring in wastewater given the time lag. Do we have a health department that has piloted a response to give some sense of efficacy?
I'm sure Randy and I could take that one. I'll take a crack at it first. So in terms of, we are monitoring a leading indicator. So within 24 to 36 hours, we have some idea if we're catching a viral RNA signal in the wastewater from a particular dorm. We can work with housing to isolate or quarantine or do enhanced test or more frequent testing within that population, and work towards squashing an outbreak before it happens. So our pilot study with State of Michigan was largely retrospective because we were gearing up basically the protocols, the equipment, and the sampling. So what's important is to mesh and take advantage of the new technologies that we could help do the basic science and engineering to bring those online in collaboration with other entities such as Randy was talking about. But what's key is to get that response, that leading indicator, and making the most of it to prevent the outbreaks. And so we're in conversations with not only the State of Michigan, but also our Office for the Vice President of Research to support an ongoing effort. SARS-CoV-2 won't be the last virus, unfortunately, that causes or could cause a pandemic. And this starts to speak to the importance of having basically an observatory and doing this wastewater-based epidemiology in a more proactive approach.
Yeah, if we can get I'll chime in on the top of that. If we can get down to real time or near real time, within 5 minutes, an hour, and then get that information to the health department or the reach of if it's a dormitory, if it's an Air Force base, or if it's an aircraft carrier, or if it's even in a city where we have multiple reaches of sewer collection. We're a good 5 to 6 days before it even is the noticeable effects of COVID are being observed by the individual. So that's how effective this is. And it will be selectable in the future. So the next strain that comes around, we'll be able to tune it in to that strain.
You're basically looking at pattern recognition, and so as Randy pointed out, the flu virus du jour or of the year could be, the system could be calibrated to that to recognize these.
Wonderful. Thank you. I think, Avinash, you have a question? I see your hand is up.
Yeah, I just wanted to say a few words. Nice to hear. Good morning, everybody. I'm driving. Yeah, nice to hear Dr. Karen Miller and Randy about water. Hi. So we are infrastructure contractor. We deal with a lot of water, wastewater infrastructure, such as pump stations, pipelines, distribution systems, and metering stations. So, and treatment processes also. So in the next session, I will be happy to share with the construction challenges and construction nuances. So that will be, I feel.
That would be a very timely discussion. The nuts and bolts of our infrastructure, and we have a very, very distinct and I think advantageous position here at Wayne State in working with the infrastructure that we have. And what do we need to do to improve this? This infrastructure was built for a different time and has actually, due to deferred maintenance, has degraded over time, which all infrastructure does. But it's under the influence of greater challenges to system capacities. So, we look forward to you all joining us in our work here.
Thank you. And again, Avinash is
Thank you.
a distinguished alum and member of the Board of Visitors of the college, the executive board of the college. And Randy also serves on our board. I'm very happy to see that, hear the presentation. And also the other thing that is maybe missed in our conversation, regulations around sustainability and environmental issues. We are bordered with Canada and Detroit River, urban watershed that Miller mentioned. We collaborate quite a bit with Windsor, at least Ontario, on those issues. What are the opportunities and challenges, Carol, that you see in partnering with Canada and addressing some of the modeling or waste treatment that you're working on?
Yeah, thanks for the question. There's lots of opportunities for partnering with Canada, and we are already doing that. Bill mentioned that I'm very involved with the International Joint Commission, which is a binational organization that works on boundary waters between the US and Canada. And so in that application, yeah, I get very involved in issues regarding things like differing levels of action. So Canada might have a certain action level for fish consumption advisories than the US side is. And that becomes very problematic when the water is common. And here in the Detroit area, you can just look across to Canada, and to think that great minds on the two different sides have come up with different decisions regarding what is acceptable in terms of, you know, pollutants in the water. I think it's very interesting and ripe to be studied how these groups can come up with more unified processes. We've worked with the Windsor utility, looking at helping them with some of their processes regarding early warning systems, similar to on the US side of the corridor. Also, you know, the idea of having a unified water monitoring system. Again, there's such a fracture between systems on the US side and systems on the Canadian side in terms of data. And it makes it very hard to look at that data together and make decisions regarding it. So the answer is there are a lot of avenues for that type of research.
But again,
It can get a little complicated because some research agencies only will fund US research. Some Canadian agencies will only fund Canadian research. So it gets hard to work across.
So that adds most of the complexity of some of the issues that we raised by the panelists as well too.
Well,
May I add one comment about the work between Canada and US? I think, as Kara just mentioned, I just want to add one comment that we do have many collaborations with the Canadian side. One example is in addition to all those efforts that Kara just mentioned, another example is our microplastic projects, because we are looking for reduced pollution resource in Great Lakes region. So we all know that Great Lakes region, we have a shared water body between US and Canada. So our effort is to, although the funding is not going to Canadian side, but we do have a well-established network and advisory board. We have people from a number of organizations from Canadian side that we can share our knowledge together, and then we can get their feedback, what have been doing in their side and what have been our side. So I have to say that's another way we work together to address those issues in the Great Lakes region.
Yeah, that again shows a significant Wayne State University in an urban setting like Detroit, and also collaboration with our Canadian counterparts, and also being in an urban that is surrounded by industry. And that is one of the reasons Dr. Miller started the work around urban watershed that really addresses that we are really surrounded by industries that have done a lot of not some nice things in the past, and now we have to deal with some of those issues now. I think we have a question from Bob here.
Yes, Bob says combined sewers were separated in Grand Rapids over 30 years ago. I lived there then, and the entire west side streets were tore up for years. This was required by federal and state edict. Has Detroit addressed the combined sewer problem? What areas of Detroit still have combined systems? Didn't the federal and state require these to be separated as they did in Grand Rapids?
So I could, Carol and Young Lee and I could take that up, but I'll kick off. Let's start from first principles here. One of the most illuminating things I learned about combined and septic sewer overflow events was from Dan Murray. He's a wastewater engineer with U.S. Environmental Protection Agency. He said, this is what these structures were designed to do. They were designed to overflow and relieve the system when capacity was overwhelmed. And so we're left with a very interesting engineering problem here, where we have to work with what we have and look farther back into the system and understand where are the capacity, where are the pinch points within the system, and understanding how do we, there's very interesting and I would say explosive hydraulics within these systems when they're under high flow conditions. These are very complex systems. There's a lot of redundancy and backwater effects that we have to deal with. And so despite real-time control and, soaking up rainfall runoff in green infrastructure or detention retention facilities, we still have serious issues that potentially could be correctable within the system, the way that they were designed. And air hammering, for one thing, is something that I've started to look into. There's been a lot of work done by Professor Carney, University of Toronto, in this area. But again, how do we integrate it across our disciplines to get a better grip on this and then feed that back up to our state, federal policymakers? Certainly the Clean Water Act enforces and regulates overactive combined sewer systems. This is a huge issue for over 800 communities around the United States. So, this involves industry. This involves focus from academic folks, and bringing that together to basically reform a system that's tends to offer more environmental insults than management thereof. So that's, if you want to add to that, Dr. Miller or Dr. Zhang.
Well, I guess I would just add, I think your question was also,
Detroit centric.
City of Detroit still have a lot of
Right.
sewers, and the answer is yes. There is the majority of the city still has combined sewer systems, and the edict that the city is under is really to limit the number of combined sewer overflows. So to limit the effluent that escapes with less than full treatment. But the city is still living with combined sewer overflows, which cause not combined sewer overflows, but also combined sewers, which in addition to the overflow problems can cause problems such as basement backups and flooding that pushes upstream into people's homes. And as Dr. Schuster mentioned, there are various policy and research options that are being considered. Changing the city to a completely separated system would be a humongous engineering challenge. And I guess maybe I'd let Randy say something about that.
There's no one solution. We've seen, Grand Rapids, Minneapolis, they separated sewers. That's the most expensive thing to do. Like I said, clients are looking for how to do more for less. So best practices. Look at the how long the Chicago worked on their tunnel and reservoir program. Finally finished. I think maybe one reservoir is still a little bit to go, but if they get a uniform rain of a half inch or more, it still that's about as much as it can handle before you're going to get an overflow someplace.
And one of the issues too is that in a separated system, when we run the stormwater runoff into surface waters, or the closest or adjacent stream or river, lake, there's not necessarily that's not necessarily clean water right there. And so again, this folds into the sustainability effort. Let's not create problems in the next set of activities. We often have one chance, especially in the area of wastewater and stormwater management, to rectify infrastructure. There's not a whole lot there, in terms of going back to ratepayers and saying, hey, we didn't get it quite right this time. Let's take another crack at it. Well, I'd like to think that Wayne State Civil Environmental, along with our cooperating colleges, are working on these issues and bubbling up some sustainable solutions.
Working with industry alumni, also I want to shout out to Dr. Perry McCarty, who's on the call, who received his bachelor's degree from our Department of Civil Engineering in 1953, and BS and PhD from MIT followed, and he's Emeriti faculty of Stanford, whose work is in the area of control of environmental contaminant. So let me hear from Dr. McCarty. What do you think about some of the work that our faculty are doing right now about sanitation and looking at the contaminant and the impact of that research? Hearing about him. Yes, I want to put you on the spot, Dr. McCarty. You're muted. You're muted.
Let's see. We do have a mute on you, Dr. McCarty.
We can't hear you, unfortunately. Can we unmute him from here?
I've asked him to unmute. I can't unmute
You can
him.
do that here from here? Okay. Yeah, you have to, on the left side of the screen, there is a microphone mute. If you have to click on that.
There we go.
It may also help to unplug and replug in the earbuds.
Can you hear me?
There we go.
Sorry.
That's
Sorry.
right.
Well, I enjoyed all the talk and the understanding. Wayne is a university is very close to my heart. A long time ago, it got me going in the right direction. So I am now trying to pull myself away from all my activities. I'm 89 years old now, so it's time to start doing some other things. But we just finished writing the last of my textbooks, so so I think now I'll just listen to what the rest of you are doing, and we've got a long way to go yet, but we're doing improving very much. So thank you very much for inviting me.
We had the pleasure of hosting Dr. McCarty last year, and it was such a tremendous and inspirational talk that you gave, Dr. McCarty. Your presence, the students just were overflowing with gratitude, and we're truly inspired. People are still talking about this, and I know I am. So thanks again.
Well, thank you very much. I enjoyed it. I really enjoyed having the opportunity to come back to Wayne. It was
awesome.
A great pleasure.
Homecoming.
Thank you, Dr. McCarty. I think we're almost, any last question? So let me kind of wrap it up because we are out of time here. I want to thank again everyone who participated. I want to thank our panelists, Dr. Miller, Dr. Yongli Zhang, and more importantly, Dr. Randy Rogers, joining us from Texas, as well as Dr. Schuster, who moderated. And also, I'm very thankful that he joined our department from EPA after working for EPA for many years. He's bringing a different perspective to work that we are doing on environmental and sustainability and also civil engineering as a whole. I want to invite you to join our next Coffee with the Dean, which will be focusing around health and wellness. It will be moderated by Dr. Cindy Burr, who was one of our alum, who recently joined as the department chair of biomedical engineering. He joined us from USC, University of Southern California. And a couple of her faculty will be on the panel talking about health and wellness, which is another goal of sustainability development goals set by United Nations. That would be on February 9th. With that in mind, I want to thank again everyone. Please, if you want to continue being in contact or have more questions, reach out to us directly or through Chris, or Audrey, or Claire. We will make sure to connect you with the right people, and follow us up on on LinkedIn and our on website, success of our faculty, the research they're doing. There's a lot more than what we could talk about in 1 hour, but there's a lot more going on in our Department of Civil and Environmental Engineering. And Avinash, who just was on the call, one of our board member, as a matter of fact, is building for us a facility for our structure lab in the for the Department of Civil and Environmental Engineering. So that would be off-campus location, a big size facility to be able to support our faculty in their structure engineers. And again, we would love to have more engagement from you in some of the work that we are doing. Thanks again, and have a wonderful weekend. Take care.